G'day, my name's Andre from Connor Architects in Geelong in Australia. I'm going to take you through all the steps to show you how I made my geodesic dome. I decided to go through the internet and check out a few designs, and ultimately I found some really easy ways of doing it, which I'm going to share with you now. So enjoy the ride, and yeah, if you want any more information, you can contact me at my website or look up my Facebook or Instagram, and I can get in touch with you and give you a hand with it all. So first of all, you've got to have some kind of design. And I went to a website that I found was absolutely brilliant, and I'll give them a plug for that. It's called geo-dome.co.uk. You can plug in your desired dome size and dome design, and it'll pump out all the calculations that you need for your various component sizes and angles and all the rest of it. The geodesic dome is made of a whole lot of little components, and the most important component is the strut connector. So here's a little model that I've made, a little prototype, and it's made of really basic materials. So as you can see from here, this is a 6-way connector, so it's made up of the individual struts as such, and the joining pieces here are just metal straps, and they've just been screwed to the struts, and they're held together by a hub, which in this particular case is a bit of PVC piping. And that's it. It's as simple as that. So I'll use the same design when I make my 5-way connector and my 4-way connector, which you'll see when you go to one of the websites that you'll need quite a number of these. So really, metal connectors there are basically just pieces of metal strapping, which here's a piece that I've already cut, and it's got lots of little holes in it. You can buy this from any hardware store. It's really inexpensive, it's strong, and it's versatile. The other component, as I mentioned, is the hub. So here's a piece of 50mm poly pipe. Again, any hardware store. I found this in a builder's skip, which I've retrieved, and you'll cut these up into appropriate pieces. So I've made myself a little jig to make my life a little bit easier. So because we need quite a lot of these metal strap connectors, which is this thing here, and which is repeated 6 times around the 6-way connector, and 5 of these for each 5-way connector, and 4 of them for the 4-way connectors, added up, you're looking at over 100 of these to make. So you can make them individually by hand, and I can show you quickly how to do that, or you can take a little bit more time, and you'll probably need a welder to make up some kind of jig, the design of which you can modify however you would like. I paste the strap there, and then I use a clamp just to clamp that strap in place. And it's a simple case then of bending the strap around, and obviously it's a little bit difficult because I'm holding the phone. Bend the straps around like that. Too easy. Take the strap away, and you've made your first connector plate. The other way you could do it, as I said, if you don't have the capability of making a jig, you could just get a piece of rectangular steel, or it could even be a piece of timber, whatever you can find around. You can then get a piece of the strap and use that. So when you go to your hardware store, you'll buy your metal strapping in a big roll, usually about 30 meters. This stuff here is 25mm thick, which suits my purposes perfectly because it suits the size of my timber struts really well. So you can cut your pieces of that using your tin snips, cut your required length. In this case, I've allowed 90mm across there, which gives me plenty of space to put multiple screws, and then I've got my pipe length there at 50mm, and then another 90mm across there, which means that each one of my strap lengths is 230mm, which I've pre-cut into little lengths like that, which makes my life a lot easier. So with your piece of timber or metal, you put it across there, and with your clamp, and again this is a little bit challenging doing it one-handed, but you clamp your piece of metal in place like that, and same sort of theory, you bend your tabs across left and right side like that, remove your clamp, and you've made another one. So only 120 to go. So that's as simple as it can be. The next most important component is the connector hub. So the connector hub is the bit that holds all these metal things together, and you can see that white surface there is actually the bit of poly pipe. You'll be cutting a number of these. We need 26 of these bits of poly pipe, 50mm diameter, cut to 50mm lengths. So how do we make these hubs? Well, if you've got a drop saw, you can put these into a drop saw and with a stopper and just keep plugging away at it. Or if you don't have a drop saw, and you've got a vise or some other clamping device, you can put them into your vise and basically measure off the length, and with your saw or hacksaw you can mark and then cut. So the issue then is about getting the connectors onto your hub, and with the 50mm poly pipe you will see that it sits in there. There is a little bit of a gap, but you will find with a bit of positioning that all those connector plates or U-shaped straps will go fairly neatly right around your hub. It's a bit hard to hold it in place if you're not an octopus, but yeah, you kind of get the gist. And then the last one fits in very tightly but neatly in there. It's not going to do it for me now, it's all going to fall apart, but anyway, you can kind of get the idea. So later on, when I show you, when I've got all the struts cut, how to put all that together. But that's essentially your 6-way hub, and that's going to be the most intricate to do. Your 5-way will be a little bit easier. So that's it in a nutshell. The next stage of the construction is to cut all my struts. There is an A strut and a B strut, and according to the plan that I've got, the A struts are marked red and the B struts are marked blue. So in this particular case, my strut length for A is 820mm, close enough to, and the B's are 927. However, because of the nature of my connector, which is a 6-sided one there, I need to make some allowance for the diameter of the inside of my connector. So looking at that, my connector, which I've measured, is actually 57mm diameter. And if we think of the connector there being the PVC pipe and overlaying the actual connector star, we can see that if our strut length is 927 or 820, we need to deduct off twice the radius of the actual hub. So one radius length on one end of the strut, and which I haven't shown, but another radius length on the other strut. So whatever our strut length is, we need to take off 2 times the radius, or in fact 1 diameter. If you look back onto our diagram, the long point of the strut is there, which is effectively the center of our connector at each end. So our effective strut length is going to be twice the diameter less, twice the radius less, which means our strut lengths, each of our strut lengths will be 57 mil shorter than what the calculation is for the actual dome. So we're then going to set up the drop saw in this case, and put a little stop end on so that we can gauge a typical length for each of our struts. I've set up my drop miter saw, put it onto a trestle, and rigged up a little saw stool at the end with a plank of off-cut plank of timber, which I'm just using as a surface to rest my strut on. And to that I've screwed a stop end piece of timber, which is at the required length for each of my strut cuts. So I've set it up so that my saw cut is there, and that will produce the required length that I've measured for each of my struts. In this case, I'm starting with the blue or B type struts, and that's because I want to use them first around the base of the dome. Now, before I crack on and cut a whole load of my struts, I want to make sure that I'm actually accurate with what I've worked out to be my length. So I've taken a couple of my PVC connector rings and set it up at each end of my strut. So if you think back to the connector star, we've measured and made allowance that each of our struts have been cut short from the overall required length by half the diameter of each of our connector rings. So the pencil mark represents half the diameter of each end. So I'm going to check and just make sure that overall, from the center of each of the connectors is going to be what we require in terms of our overall plan. So that's measuring there 927. So from the center of that connector ring to the center of that connector ring, if you can see the pencil mark there, is 927. And if we go back to our original plan, which I like to do, our blue or B-type strut had a finished length of 927, which is exactly what we've worked out that it is. So we know we're on the right track. So having checked our strut length against our plan and our control mechanism, we can now go ahead and cut 35 of these B-type struts, which is what our plan calls for. So I'm going to go ahead and do all those cuts and see you in a little while. Since last time, I've been working on the base of my dome, and this is the set out procedure that I've used. So the base is 10-sided, and I made up myself a template just on a bit of scrap plywood, which has a circle on it, divided up into 10 equal spaces, and that gives me my set out diagram. From there, I just use the string line, which I've got here, which I then rotated around to each of the 10 angles, put a mark on the ground at each of the point, and I've come out 1.5 meters from the center line of the template because I'm making a 3-meter diameter dome. Half the diameter is the radius of 1.5 meters, and then I've just stepped out or marked out all the vertice points of the base. What we've got now are the base stumps that are in the ground, and there's one stump at every intersection of every base point, and they're all aligned to the radial axes coming off that template. So the bottom ring has been installed, so the bottom plate, and that's 10-sided, and the angles are the same as for the blue struts. So same 18-degree angle was cut at each of the intersections, both sides. So then 10 pieces, and they've been screwed down to some timber stumps. Having a final look at the base of our greenhouse, and I thought I'd do a last minute check just to make sure that our base is true and center and everything. So what I've done is I've stretched string lines from one corner to an opposing corner, and I've done that to each opposing corner, moving around so you can see that. And amazingly, all the string lines meet up dead center in the middle. There's no gaps or nothing's out, so I'm actually really wrapped with that. And I've also done a final check on the overall dimension of our dome, and this one, as I mentioned very early on in the video, is a 3-meter diameter dome. So you can see there it's pretty close to 3 meters, and I've checked all the opposing angles, and they're all within about 5 mil of each other. So I'm very confident that our base is correct. So having made all the struts, I decided to have a crack at getting straight into starting to make some of the components. In this case, I've made one of the 6 pentagons that make up the entire dome structure. Now, I thought I'd just quickly show you how to make one of the, or a couple of the connectors. This is what I've code marked, one of the B struts, or the blue struts, and which forms the perimeter of one of the pentagons. So we've got our metal strap, which I have sort of racked a little bit, so you can see it's got a bit of a kick in it, and that's really to take up the angle that the PVC pipe makes with the actual strut angle. So pretty simple. Put that in there, put it over the top, grab a screw, put it in, and flip it over, and make sure that that pipe is pulled up nice and tight to the timber, like that. Needs a bit of coaxing. Make sure that's bent over nicely. Now I'm just using galvanised plated screws, so the little screw head sometimes is a bit fiddly to get the screw gun into. So in terms of assembly, I'm only putting the one screw in on each side, and that's really because once it's all together, I want to be able to have a little bit of movement in there in case that I need to jiggle the whole thing around to get it all to fit. So as with most things with this project, it's all a matter of repetition. So, you know, once you've made one joiny thing, you've pretty much learned how to make all of them. I'm sure you'll find your own way of best putting all this together, but that's the in principle way of doing all of your joins. When I'm making my pentagonal, I start off with a triangular piece. So that's the base, which is the blue coated B strut, and these are the internal spokes, which are the red coated A's. So I found that by creating this first triangle, it makes it easier to add to it, add the other spokes and the other components when you're making your couple of pentagons. So again, the methodology is the same as I've showed you before. Of course, it does get a little bit trickier because getting to the other side means you've got to put the whole thing upside down. But that's where perhaps if you had somebody to give you some help in holding its timber in place, that would work out to your advantage. You can get the screw in, that's the help. And yeah, that's pretty much it. So I've made up all the pentagons now, and had a bit of a rethink on how to put this whole thing together. And rather than doing it stick by stick, I thought that what I would do is put together all the pentagons I need completely with all the connectors, and then I would put some pieces of plywood or timber to lace across these corners. And the reason I've done that is because I've worked out that I can have one complete pentagon, which is this one here, and then as I work my way around the base, I can have almost complete pentagons except for one corner. I've stood up my first pentagonal component, which is the one that's fully made with all the connectors. I've got a little prop there with a clamp that's just holding it in position. No big deal, nothing fancy. And I've lined it up here so that the middle of my connector pipe there is lined up exactly with the intersection of the base. So it's a bit hard to see with the sun in that angle, but you can see here the center of that pipe is the center there. So what I was explaining before is with the next pentagon that I'm putting on, I now need to actually remove this bit of plastic. So I'm going to unscrew these. So I've undone the screws on both sides. Brackets are just sort of flopping around there. They can all just kind of come off. So I'll just take you through joining one of these hubs with the plywood lace on it. Kind of one-handed. So the idea is to thread all those metals through the joiny. There we go. It's all coming through. So here's the join that I took the connector pipe out of, and I've just threaded these metal brackets into the adjacent pipe, and I'm going to leave these plywood gussets on until I've done all the pentagons right around. So here it is, the first layers of pentagons are on, and from here we really only have to top off the top. And then we will need to put in these other base struts across there. So there'll be 5 of those to do. The roof, or the peak part of it, I'll prefab a star shape, so it'll be a 5-armed component with the ring in the middle, but yeah, there's not a lot of other prefabbing you can do with that one. So here's the 5-sided star, which will be the top of the greenhouse, which I've prefabbed in pretty much the same way as all the other joins. So yeah, PVC pipe, metal strap, but I have actually screwed them off completely because it might just be a little bit trickier to get to later on. So yeah, the next thing is get up the ladder and put it up there. So I'm just going around now and putting the last intermediate bottom struts in where required. So they just kind of pop in there, like it's all been cut very accurately. So yeah, just pops in, and then we'll just put these brackets on them, both sides, and screw them off. So once you've got your peak star up and connected, you'll then need to put in the other cross struts across there. I already put one in there, and I just need to do all the others, and then that's pretty much the frame done. So then just go around to all the joins and make sure you've got the right number of screws in. I'm using 2 top and bottom for each, so yeah, just go around and just double check that you've got all the screws in, and then you're pretty much done. So right at the start of the process of putting the pentagonal frames together, I think I mentioned that these bottom connectors, I just sort of screwed them temporarily, and the reason for that is that there is a gap here between the bottom strut and the top plate, and to eliminate that, I've gone along with a like a paint stripper heat gun thing, and just heated that inside, and it's just collapsed pretty much under its own weight, so that I can then pull that down so that it's much closer to the bottom plate. So I've done that around here, and it's actually really tight, so I'll be able to get some screws into the top, into these struts, and screw it securely to the top plate. So after you've gone around and fit off all your remaining screws wherever they are, so yeah, all your brackets have got the right number of screws in them, tested it all, it's all good, and yeah, you can stand back and say, that's my dome. So what I'm doing now is going around and putting these protective plastic covers on all my connector plates, and the purpose of that is to protect the plastic sheeting that goes over the top, because there's still sort of sharp edges around screws and things that could tear the plastic, so that's the little job. I've also cut the door opening and put a little door frame around the entry. So today I spent a fair bit of time putting the plastic on the dome, and I've been putting on these timber straps over the top. It was quite a task putting the plastic on, also because it was quite windy, but I managed to get most of the plastic on in single sheets, with some laps where I just couldn't get it to bend over, but it's a pretty neat job, but it is a bit time consuming. Having put all the polyplastic over the top, and installing all the strut slats over the plastic to hold them in place. I've started on doing the openable hatches in the roof, so I've got 5 to make. They're going to be a bit tricky. I've started making one which you probably can't see very well, but they'll be hinged so that the dome can let the hot air out of the roof, because it's going to get quite warm in here, particularly in the summertime. So each one of those triangles opens and can be adjusted via a pretty simple sort of bit of copper pipe with a few holes. So you can adjust them down to whatever height you feel. I've only got three stops. I feel that's enough. And yeah, when they close down like that, the little lever just parks in a little hook there, and yeah, I can close them all or open them all or do whatever I like. So yeah, that provides me with a bit of climate control. So after a lot of additional work, the dome has now reached the stage of completion where things are planted inside. So I'll just take you for a quick walk around just to have a look at the finished product. So as you can see here, this is the outside. We've got some plinth boards installed around the edges so that the mower won't damage the plastics. We've put all the cover strapping on over all the plastics on the outside there, and we've even got a front door. So that's the way we get into our little dome slash igloo. So I'll just take you in. So we've got some planter beds constructed inside as well. Again, that's just kind of going around the outside, following the line of the dome, and yeah, it's actually quite a magical structure inside. It's actually really nice to sit and just contemplate the world. So here's just a very quick tour of the completed dome with the roof flaps in their fully openable position.